Hey, I know this is the last class, but please hang in there. Like my 7th period class yesterday, or not yesterday, actually two classes ago for them. They're getting in this bad habit of thinking because it's the end of the day that I'm going to stop teaching with like 5 minutes left. We teach until I'm done. So just keep that in mind because nothing frustrates me more than when kids decide class is over. Contrary to popular belief, you don't. I decide when class is over. If I'm still teaching, you need to still be a student. All right, so, for a line, we talked about this last class. I'll show you just one of the slides. We said that if we took an equation and if we created a whole bunch of x and y values that make that equation true. So our equation was, I don't know how much of this is going to erase. It all erases all. Oh, there we go. Perfect. So we said the equation was, in that case, was x subtract y equals 0. Well, we said there's an infinite number of numbers that will make that true. Basically, we just need to make x and y the same number. Because if you take a number and you subtract it from itself, you get 0. So we said we start out with just 2, 4, 6, and 8. No, 0, 2, 4, and 6. Then we plotted those on the graph. Then we did 1, 3, and 5, and we plotted those. And then we just kept adding more and more and more and more numbers. And as we added more numbers, this started to happen. Those coordinates, those x and y values, that all of these are x and y values. As we plotted more of them, they got closer and closer and closer and closer together. And I told you I could plot an infinite number of these because there's an infinite number of numbers that exist. So I could keep making every number a little bit smaller. So 0.01, and then y would be 0.01, and then x could be 0.001, and then y would be 0.001. And I could keep making the number smaller and smaller, and eventually they would be so close together that you couldn't even tell there was any space, and it would just look like a line. That's what a line is. It's an infinite number of x and y values that make the equation true, because all of these numbers over here make this true. And they follow a pattern. Like the equation is kind of like the rule or the pattern we talked about. If they didn't follow a pattern, they'd just be all over the place. They just look like a bunch of random dots everywhere. But the reason that they form a line is because they follow the same pattern. Every time we add one of them, like for example, if we had this equation, every time we change the value of x, well, the value of y is going to have to change and be that same value of x. There's always a pattern to it if they form a line. So that's what we said a line was. Infinite number of points or coordinates that follow a pattern and that will eventually form a straight line. So now moving into the next question, we said, well, if we've got this equation, again, which is what we had to form all those points, the x subtract y is 0. If we've got this equation, every single point on that equation has got to be a solution to the equation. Like that's how we made the line. Every single point is a solution. So in that equation, if I took any of those points that I graphed, 7, 7, well, that 7, 7 was going to be on the line. That's literally how I made the line. It's based on making that equation true. So if I tell you that the coordinate x, y is on a line, that means whatever the values of x and y are, they're going to make that equation true. That's the equation that they go with. That's the line. Because we could make a line out of this, just like we did the x subtract y. We could make a line out of this. That would create a line. It's a linear equation. So my next question is, this is 4, 6. I told you that's on the line. How do I know that's on the line? Nicole, how do I know that's on the line? Well, we don't have a graph. Like we don't have a picture. If I had a line graph, then yeah, you could look at it and say, well, yeah, see, it's on the line. But I don't have one. So how do I know it's on the line? It's another way I can tell if it's on the line. Guaranteed test questions coming up. The next few things that I do are guaranteed. because they're easy for me to grade, and yet still hard for you to answer. You don't have to do a whole lot of math on them, but you need to understand math, which is why I love them. Easy for me to grade, and they're something where I can tell whether or not you understand them. Sort of. You could just memorize them. How do I know? What did we just say? The line is made up of what? What? You know. I thought somebody said something. And what's true about those x and y values? And a pattern, and how do we get that pattern? How do we get the pattern for the x subtract y equals 0? Where do we get the x and the y values from? And I just say, well, I'll say x is 4 and y is 6. Or I'll say x is 10 and y is 100. Is that what I did to get them when in that other thing that I did? What did we have to do to get them? I created a whole table, remember? Whole bunch of values. Where did I get those values from? I'm going to go back. Where'd I get all those values from? I know you can't see them, but all those values came from that equation. So what did I do to get them?
Math.
What math?
Line math.
Nope. Hey, quiz is going to be funny when I grade it too. So I'll laugh along with you when I'm grading it. I'll just laugh. Oh boy, this is funny. 0, 0, 0. So you can joke around if you want, but this is, again, this is what you have to pass to graduate. I don't care if you got straight A's. You're going to have to pass a math state exam to graduate high school. And this is basic stuff that'll be on there, guaranteed. These are the easy ones. So where did I get those values from? I'll give you a better hint. Something maybe you can see. Whoop. Whoa. Those values come from? Well, no, I made the table with the values, but where did I get the values? How did I know x was 0 and y was 0? X was 2 and y was 2.
Because they both have to be the same.
Why? Why did they have to be the same?
Because there's an equal sign.
Yeah, but that wasn't. There, now back to this. How did I know they had to be the same?
Equal itself.
Closer, getting there.
You have to put them together. Do the math together.
I don't think this will draw. That won't draw. So again, an x and a y coordinate make the equation true. They make the left side, and when I say make the equation true, what that means is they make the left side equal the right side. The way I got every single value there, every single coordinate, these are all coordinates. I'm not going to write all of them because I can't fit them all on there. 0, 0, that is a coordinate. The way I got that coordinate is I said, well, 0 subtract 0 equals 0. This was a coordinate. The way I got that is I said 1 subtract 1 equals 0. I can pick any two x and y's that I want as long as they make the left side equal the right side. Well, in this one, that meant they were equal. But that's not what it means in this one. Why is it doing that? That's not the smart board. There we go. In this equation, what's wrong with this thing? In this equation, they can't both be equal. Because if I plug in 1 and 1, 1 does not equal 1 plus 3. So that doesn't make it equal. So they can't be the same number in there. So I got to move on. This is my x. That's my y. X is always the first. Y is always the second part. If that line, or if that coordinate is on that line, this is a line. The equation represents the line. That's how we would draw it, is from that equation, just like we did the x subtract y equals 0. that point better make that equation true. It better make the left side equal the right side if it's on that line. That's literally how we create the line, is we take this and we come up with a bunch of x and y values that make that equation true. That's how we created the line with x and y, right? We said all the numbers that make x or y equal, x subtract y equals 0. So I can take my y of 6 and just plug it in for y right here. So I'm taking that 6, plugging it in for the y, taking the x, plugging it in for the x. Is that a true statement?
Yeah.
Then that point is on the line. If this point, when we plug it back in, makes the left side equal the right side, then that point is on the line. That's what a coordinate is on a line. That's how it relates to the equation. Because remember, we literally created the line in the other example. We created it by coming up with all of the x and y values that x subtract y equals 0. Hmm? So let's see if we understand that. Who am I going to call on? Let's go with, I already started on that in Anthony. Renai is going to be next. Give me another x and y coordinate. Another coordinate, another point. It's going to have an x and a y in it. Give me another one that's on that line. So 4 and 6 is on the line. I just proved that. Give me another one you think might be on that line. If you don't know, give me an x and a y. And we'll just test it to see if it's on there. So say x equals this, y equals this. Whoop. What in the world is it doing? That didn't work. Huh. Don't know why it's doing that. Keep going, I'm listening. X equals what? Oh, maybe that's why. X equals 5. What do you think y would need to be? All right, so x equals 5, y equals 3. I think you're on the right track. So Anthony said x equals 5, y equals 3. So again, remember, my first one is always x, my second one is always y. So we need to be able to plug these in to that and get a correct equation if those are on that line. So I plug in y of 3, because that's my y value, x of 5, and then I just add in the plus 2. Is that a true statement? No, we got 3 equals 7. Not true. You're kind of on the right track. But you did the, I think you are. You did the math a little off. Renaya, give me a point that you think could be on that line. So again, the line that's created from this equation, what's a point that would be on that line? So x is 4, y is, let's try that. Well, no, that's already on there. I already did that one. I want you to give me another one. Any number you want. You say x is this, y is that. Any x and y you want if you think it's on that line. Because there's an infinite number of them on the line, remember? The line is made up of an infinite number of coordinate points. So you take 4 and 2, so x is 4. I'm going to write it up here. So you think x is 4, y is 2. All right, well, I should be able to plug those in, and I should be able to get A true equation. Is that a true statement? No, 2 does not equal 6. So that one didn't work. And we already had an x of 4. X of 4, y had to be 6. Can't have an x of 4 and have a different y if that other one's already on the line. Don't worry about that right now. What do you think?
5 and 7.
Let's try 5 and 7. 5 and 7. All right. Well, 7 equals 5 plus 2. Is that a true statement? There we go. That's a true statement. That is on the line. Because it made that true. If you'll notice, remember, they follow a pattern. What's the difference between these two numbers? Like, literally the difference. Subtraction. What's the difference? 2 apart, right? What's the difference between these two numbers? 2 apart, right? Well, that's because we're adding 2 to the x value every time. They'll always be 2 apart. Every x and y value that are 2 apart, assuming that the y value is 2 greater, every x and y value that follow that pattern will be on that line. So again, the x and y values that make the statement true are all on the line. So here's what I'm going to do on a quiz, and you'll see it on state and district stuff too. Just I'd give you an equation of a line, just like I did here. I'd give you a whole bunch of coordinates, and I'd say circle every coordinate that is on that line. Well, if it's on the line, when you plug them into the equation, it better make the left side equal to the right side. If it doesn't, then it's not on the line. If it does, then it is on the line. Simple as that. Super easy for me to grade. It doesn't involve a real high level of math knowledge. You just got to plug some numbers in and do some math. So like I said, I guarantee that's going to be on a quiz. I could also ask you, give me one point that is on the line and make you create a point. So all you'd have to do is plug in any value you want for x and then solve the equation out, and that will give you the value of y you need to be on the line. So if I wanted to find another point on that line, I could just say, well, I'm just going to make x 1. I'll just say x equals 1. What would y have to equal? 3. You just plug it in. Again, all I'm doing is I'm saying, well, if x is 1, I plug in 1 for x. Then I add 2. Well, that means y would equal 3. So my coordinate would be 1, 3. That would be on the line. Because I basically created it by using the equation itself. So I know it has to be on the line. I could plug it back in if I wanted. 3 equals 1 plus 2. Yes, it does. So that's on the line. All right. Boy, that took a lot longer than I wanted it to. So we will have to hustle through the rest of the stuff. Oh, God, what is wrong with my smartboard? There is a lot of review stuff in there. There we go. Just taking forever. So quick review. We talked about, again, equation is a rule. We have to follow the rule. That's why we can create a whole bunch of x and y values. It's because it always has to follow that rule. X subtract y equals 0. In the last problem, y equals x plus 2. In the word problems, these were the rules in words. We said that there's we just talked about the other piece. When you graph, you go left or right first. Remember, when you're doing graphing, left or right first. I told you the story about Miss Graff, the woman I almost married. I went left or right first to get to the elevators. You missed an amazing story. So left or right first to get to the elevators. Then you go up and down. We talked about this formula, y equals mx plus b. We said slope was the m value. We're going to talk a lot more about that today. That's kind of what your lesson is today. Slope and y-intercept, and then graphing. Oh, if you didn't grab one of these, come grab one of these. So I know some of you did, but come and grab them real quick while I'm wrapping this up. So that's pretty much the review. Where are my glasses? Oh. There we go. All right, so some of this will hopefully ring a bell, like you did this in 8th grade. It didn't, wasn't as effective as I thought, or not really effective, but it wasn't as sort of memorable, I guess, in my last class. They didn't remember most of this stuff, so we wound up having to go into a lot of detail, but we'll see how you guys do. First thing, remember subtraction is the same thing as adding a negative. That'll come into play later. So graphing linear equations. We're going to be taking an equation and graphing it, and we're going to be taking a graph that already has a line on it and creating the equation. That's what your worksheet is all about. What you need to understand to do that. So here are some linear equations. Y equals 2x plus 1. It's in this format. It's called slope-intercept form. The reason it's called slope-intercept form, nobody calls me. Reason that it's in slope-intercept form is because two pieces of this equation are the slope and the y-intercept. So we kind of talked about this before. That's the slope. Okay. Hopefully writing.
I remember that.
That's the y-intercept. Yeah, it was only last year. Although I know that last year it kind of got interrupted. So that's the y-intercept. Did I circle the x? All right, so first thing, and I guarantee you someone will still do it today. And I'm going to take this ruler and I wish. Because I guarantee you, well, I don't guarantee you, but last class, 2 people did it. So I wouldn't be surprised if somebody still does it.
What about this?
The x is a variable. It's one of the coordinate points. It's part of the coordinate. X is part of that. It is not part of the slope. Slope is totally, because remember, what's the math going on between this m and this x? What's the math going on? They're next to each other. What does that mean? What's the math going on between the 2 and the x? Tell me you don't remember that. It's like day 1, whatever it is. What's the math going on? Somebody, I hope somebody knows it.
Addition.
Is there an addition sign there?
Yeah.
Yes.
In between the 2 and the x?
Oh.
It's multiplication.
Multiplication. If there is no sign in between either a number and a variable, or we said it could be 2 variables, like this m and this x. That means that's multiplication. That is m times x. They're not the same thing. Like this m is separate. That is the slope. The x is part of this coordinate. We're going to multiply them together at some point, once we know more information. But the slope is never, 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 ever, mx. Or in this case, it's never 2x. It's never 3x. So we can kind of move into this. The slope is 2. These are, again, very easy questions for me to ask. These are the questions, by the way, on almost every quiz. I put some questions on there, and I'm like, okay, these are the questions that, even if people are struggling, but they're at least trying, they're taking notes, these are the questions that are going to allow them to get some points and possibly pass. Because there's not really any math knowledge necessary. Like, you don't have to do any calculations to look at this and know 2 is the slope. You just have to know it's with the x. Now, one quick note, if this were the equation, 2 is still the slope. It's the number that is with the x, the number that's being multiplied times the x. It's not just the first number in the equation, because sometimes kids get confused and they think that whatever the first number is always the slope. Well, 1 is the first number here, but that's not the slope. It's the number that's being multiplied times the x that is the slope. So in that first problem, the 2 is the slope. All right. The 1 is the y-intercept. We'll go over what that means in a little while, but for now, you just need to know the value that is all by itself, not with the variable x. So there's no, it's the one-time number, if you remember when we did word problem. The popcorn, the membership fee, the number of kids going in the cars, the one that's all by itself, or whatever the number all by itself is, that's the y-intercept. So I'm going to let you guys catch up a little bit on taking notes on that. You're going to see it a lot, but you might as well write it down real quick today. And please write in there that the x is never part of the slope. It's only the number. Because as soon as I see, unless you were absent, as soon as I see you write an x in there, I'll know you paid absolutely no attention, you took no notes, so you basically don't care what grade you get. Care what grade you get? So, let's call on some people. We should call on some online people. Let's do that. See if they're there. Who thinks anybody's there?
Just like 2 kids.
3. There's 3 logged in is all, so there can't be more than 3 that I could even possibly call on. So let's call on Lysiana. Welcome to being online. She used to be in one of my face-to-face classes. Are you there, Lysiana? If you're there, you can type into the chat because sometimes my speakers don't work and sometimes I know your mics don't work. So Lysiana, are you there? Like I said, type into chat if your mic doesn't work. Going once, going twice. Oh yeah, and I have kids that log in and then they just go right back to bed. And the reason I know they do that is because when I end the meeting and I tell everybody to go, they're still in there. That happens all the time. All right, so let's go on to Yasmin. Are you there? Yasmin. Well, sometimes it takes a minute because if you're talking, Yasmin, I can't hear you. You might be on mute. You can type into the. There she is. There she
It's
is.
just that my dog was.
All right, so Yasmin, I just asked a question and I'm going to ask it to you online. Well, I didn't really ask a question yet. We just went over something though. So in this problem right here, tell you what, I'm going to even go to all. In this problem right here, the bottom one right here, what is the slope in this equation? So I'll even circle it in blue so you know. So in this equation right here, why did I put my pencil in there? In that equation right there, what is the slope?
Five fourths.
It is 5/4. Good. All right. So even if you weren't paying attention, it wasn't a hard one to figure out. So easy question. Good job. So there's Yasmin. So I'm going to come back to somebody face to face now. Who am I going to come to? I need to go to this side. Cassie. We'll go to Cassie. Right up front. Right in front of me. What's the y-intercept? I'm doing this one still. And this one, what's the, not the slope, the y-intercept. -1, right? Piece of cake. Like I said, these are the gimme questions. I might put 5 equations on there on the next quiz, and I may say, just tell me the slope, tell me the y-intercept. And all you got to do is say, okay, well, I know this number, slope, this number, y-intercept. You write all this down, you're guaranteed some points on the quiz. No, that won't be enough to pass a quiz. It's not that easy. Question? All right, I guess now is not a bad time. So I think this is the pass right here. So let's go one more. Aaron, what is the slope on this one right here? Ooh, close. Closer with 1. What did you say? Wait, what did you say? Nope, not exactly. You got the harder part of the concept. What did you not include with that 1? There you go. -1. Remember, if there is not a number in front of the variable, there is a number there. It's a 1. Because again, if you have 1x in your hand, you don't really write a 1 in front of that. You just that you have 1 of them. So if we have 1x in the problem, we don't really need the 1 in front of it because there's only 1 of them there. This, however, is technically 3x's. This is 2x's. So we need to put the number there to know how many we have. We see the x, so we don't really need a 1 in front of it. So the slope here so the slope on that problem was -1. Close. I don't know why that's. I feel like I asked a hard Christian. I have faith in you, Christian. On this one, I'm going to ask you 2 questions. What's the slope? That's easy. What is it? 3. That's an easy one, right? What's the y-intercept? Haven't really gone over that. Ooh, what do you think? Did you hear what she said? Say it again. She says 0. What do you think? No idea? You can agree or disagree with it, though. You still agree or disagree. There is a number here. It is 0. But we don't need to say +0 in equations. I guess I'll write it. I'll tell you what, I'll write it in a different color. We don't need to say +0 in an equation because that doesn't add anything to the 3x. So we don't write it in, but technically the full version of that equation is 3x plus 0. So therefore, our y-intercept let's use that. So technically, or therefore, our y-intercept is 0. So if you don't have a number there, remember it's +0. Here's an even trickier one. Oh, that was kind of cool. I don't know why that happened. What if I had this? What is the equation for that? Can I ask that? You think you know? Ask that. Frankie. What do you think, Frankie? What's my equation there? What do you think? What do I have? What piece do I have? If this is the original idea, I should have of the slope times x plus a number. What do I have in this? Do I have a piece of that maybe? Do I have, what would the slope be with though? Huh? So we have the y-intercept. We have a number that doesn't have a variable. So this 6 is the y-intercept. So what do we not have then? We don't have the slope. Again, how do I get rid of something? If I didn't have it up here, what did I do? I didn't have the y-intercept, so what did I say it was? So what do you think the slope might be? Yeah, it's 0. Because remember, if we have 0 times any number, 0 times any number, doesn't matter what it is, equals 0. Let me do that better job than that. So 0 times any number is going to equal 0. And it's really just going to go away. So technically, this bottom equation, we could say, is 0 times x plus 6. So no matter what number x would be, this whole term is just going to go away because 0 times anything is 0. So that's why it's just y equals 6. If you see that on a graph, which you will, guaranteed, the graph would look like this. The line would be a horizontal line that goes through 6. That's what a zero slope looks like. It's a flat line or a horizontal line. Because we have to make sure that y is 6 everywhere on that line. Because remember, it's a rule. We have to follow that rule. That's what an equation is. So here, if y is going across like that, no matter where we are on the x, like if we're way out here, well, y is still going to be 6. If we're way over here, y is still going to be 6. We've got to follow that rule, and that's the only way to follow it, is to make a horizontal line. So if you see a horizontal line, it's got a slope of 0. That's one of those trick questions that they're guaranteed to put on like your district and state stuff. I'm not sure exactly how they would create it or word it, but there's going to be something on there about a 0 slope, no doubt. All right, so real quick, shouldn't take long. I'm going to walk around. We kind of already did that page. Do these. You don't have to copy them down. Just write number 1. Well, you can write 1, 2, 3, 4, 5, 6. Right at the top of those. So like this. 1, 2, 3, 4, and then down. Write slope, y, and you don't even have to write all of that. Just write y-intercept, and then just for each one of these, write the numbers they would be. You don't have to copy anything down. They're all pretty similar to the ones we just did, so nothing super complex. I'll give you like, and you guys online, I want you to do this as well. Probably, I don't know. Well, I don't know how I'll get you. You may submit this with your assignment that you're going to submit to me, the worksheet you're going to submit. Worst case scenario, I'll probably just ask you questions on it on the next quiz or something about it. Like I said, these are the easy ones to get. Amarian, wake up, bud. These are questions you've got to be able to get on the quiz. There. Amarian, home, bud. Wake up. You need to be doing this part. Everybody needs to be doing this stuff. So what we're doing right now, Renaya, I just gave them 6 equations. I said just write, you don't have to copy the equation, just write numbers 1 through 6. Just at the top, write slope and y-intercept, and then just tell me what number is the slope. Tell me what number is the y-intercept. And this is very similar to what I might do on a quiz. I could do this same exact setup right here. Again, easy for me to grade. Shouldn't take you a long time on a quiz, and it shouldn't be hard. So it should be some guaranteed points for all of you. And if you don't get points here, then I know you really were tuned out in class. Because there's no math involved. About the trickiest thing is some of these that don't have 2 parts to them. You do have to remember, and again, you can just write down the examples in your notes and go back and look at them. So you do have to remember that if there's a subtraction sign in there, technically this is negative 5x plus negative 8. I guess I should put y equals. So technically that's the equation. So when you go to pick the b value out, you have to include that negative sign with it. All right, so I'm going to walk around and see how we did real quick. You don't have to write the equation. Stop writing those. Just up here, just write slope and then y-intercept and just pick the numbers out. I'll come back and check. Somebody already broke my rule. I told you somebody would do it.
What the heck,
Oh,
Dad?
you did too.
I even wrote it down.
Oh, you don't have to write the. Okay, that's fine. I mean, you didn't have to write the equation, but if you want to do that way, circle it. That's fine. Looks pretty good. Looks pretty good. What'd you get for 6? Good. Fantastic. Is Nathan doing online learning, or is he?
He came back last month.
So you both came back? Never. I've already had 2 people include x with the slope. Remember, the slope is only the number. I knew somebody would do it. Already had 2. Oh, so remember the slope goes with the x value. Is there an x value in 6?
No.
So you flip those. I think I told you the wrong thing too. Somewhere. Oh, you weren't done. So a lot of people are not getting 6 correct. No, you did not. Look at number 6 again. You got it wrong. Look at number 6. The slope goes with the x term. Is there an x term in number 6? There's no x. So there's. So what's the slope if there's no x value? 0.
Bro.
I didn't look over all of them. I mainly looked at number 6. You're forgetting some negative signs on there. So make sure you go back and look at that. I think most of the other ones look pretty good. Hello. No, so these are not x and y coordinates. So you don't want that. Slope, and then there's a y. So you would just. Yes. Well, you're getting split. The slope is determined with the x. So in that first problem, -5 goes yes. That's the slope. The -8 is the y intercept. The part that's not with the x. And so, and again, these are going to be the kind that you got to get right on the quiz. Oh, you're not. Even though you do answer questions all. So this part is where you get the slope from, not the y-intercept. It's 50x. So remember, so what they're doing is those problems up there, slope and y-intercept. So we probably need a little on that. You do when you go to a new class?
Yeah. We can check in.
Okay, so there is an x term in number 4. So the slope would be 0. When we say if you have an x, there's actually a number in front of it. You just want yourself that. And it would still be negative. Don't forget Ms. Holtz will help you with that. So yeah, he got a couple of them flipped, I think, the intercept versus the slope. Like he's looking at the wrong number. Good.
The y-intercept.
Good.
Is always the
Good. All right.
So
I think we're
right
good.
now,
Put the
why?
negatives
No,
on.
Nancy did it incorrectly.
Well, no, some of these are negative too. So
This is
remember, I just
y
rewrote that top one. I memorized that one. Y equals -5x plus -8.
Because there's nothing there, you should put 0, did
Number looks like a
So
mountain.
it's a subtraction problem.
So the number in front of that is always.
Bro, shut up, you're confusing me.
Oh
my god, I had it, that's -5.
Yeah, they're
You
all-
said, oh, it's -0, oh, no, it's -5.
What's in front, what number is it?
This
Number
one's
2?
right here.
So what's in front of the
There's no
x?
x in number 6. There's no x term, right? So if there's no x.
That's your
and the
slope.
slope is 0.
So change it to
That's
2.
the y-intercept.
And then what's your
The
y-intercept?
y-intercept is determined without the x.
What?
We didn't say that, you
Sure that.
just said it.
It is easy. He just wants
All
you
right,
to-
so a few of us were still struggling a little bit on that, but I think we have a better understanding. That's the part of the test though you're going to need to get 100% on, because then there's going to be some other stuff that you're going to struggle with. Now you can still get partial credit on the other stuff, but this is kind of like the two-step equation. Like I put the two-step equations on there to give you some problems that you should get 100% on. I'm going to put some of this stuff on there to give you some problems you should get 100% on.
What's the 2?
All right, so let's go ahead and move on. So here's what we're going to do with the worksheets.
Right and left.
We're going to be graphing a line from an equation. So they're going to give you an equation in this format. So again, you'll have a number all by itself. I'm sorry, not a number. You'll have the variable y equals then some number times x plus b. Now you might be missing some of these because x might be I'm sorry, m might be 0 or b might be 0, but it's still that you could rewrite it in that format somehow. You might just have to put a 0 in there somewhere. Real quick, again, slope and y-intercept definitions. The slope is, the technical definition is it's the distance between your y values. So if you take a line, and if you look at the two points somewhere on that line, doesn't matter where they are, the slope is the vertical distance between those points divided by the horizontal distance. The y-intercept is the value of y where the x value is 0, which is basically just saying where the line crosses over the, don't worry, I don't expect you to get any of that. I'm going to show it here in a second. We are going to come back to these at some point, and hopefully you have a better one. I just wanted to introduce it there. So you do have some positive and negative slopes. They're going to look a certain way, so we're going to go over that. So here's what you're going to do on the worksheets. Two things. They're going to give you an equation. Oh, first, before I do that, I do want to do the positive and negative thing. If you have a line, that's my line. There's one thing you should be able to identify immediately, well, really two things, but always one thing. One thing you should be able to identify immediately about that line as far as the slope goes. Does anybody know what it is? Anybody remember that from 8th grade? This is the first thing I want you to think of every time you either see a line, or if you see an equation and you have to draw the line, you need to be thinking this immediately. First thing you think. Nobody has any idea of that one thing that you should know before you do any math? Oh, but it is about left to right. It's about one other thing besides the left to right. Oh, and it's about up. So if I started that line, I started the left. I'll use green. So I'm going to start down up. Who's new? Raise your hand if you're fairly new here. Oh, you don't know, Nathan. I'm a fantastic artist. I'm about to prove that to you. There you go. That's me. I'm on the left side of that line. I'm going to walk up this line. It's kind of like stairs. We'll make it stairs. Doesn't have to be stairs, but I'm going to make it stairs. Could just be a slope, which is literally where that word slope comes from. It's a slope. Or actually, maybe the word slope for mountains comes from math. I don't know. So if I walk up that, I'm going in a positive direction. Like I'm getting higher. Getting higher is a positive number. So a line going up left to right has a positive slope. No math involved. You should know immediately when you look at a line that is going up left to right, the end result is going to be a positive number. Or if you don't have the line and you're going to graph it, you should know when you get done, you better have a line that's going up from left to right. Now, if I have this line, does that slope up if I'm on it from left to right? No, I'd be walking down. If I'm starting on the left side of that line, I'd be very careful on this line because it's very steep, which actually tells you something also. The steeper the line, the higher the number part of the slope. Yeah, you'd have to be very careful on this one. So I would very carefully, who is next? Somebody had asked me. Okay, so you take that. So I would very carefully on this slope, I would walk down. Down is going negative. Like if you think about going down into a basement, you're going underground almost, down into a you don't know really what subways are probably, but down is a negative number. So that is a negative slope. Always left to right though. You always have to start at the left part of the line and move to the right side.
So the number in front of the x would be negative, right?
Well, yeah, so this number being your slope would be negative if we had a line that was sloping down. And vice versa. If you had a -1/2 here, when you finished, your line would be sloping down to the right. So before you ever do any math, you need to be thinking about, well, is this going to be a positive or negative slope? And then how should my line look based on that information? So what do I immediately know about this problem? Is my line going to slope up from left to right or down from left to right? Up, because it is positive. So when I finish this, I better get a line that slopes up. So here's how we draw the line. I know, and I'm going to take the short version because we got to get to the worksheets. I know one point that's going to be on that line already without doing any math. And I could do a whole bunch of math and figure out a whole bunch of points because I could just plug in different numbers for x and solve for y. Can anybody tell me the one point that I absolutely know?
0.
I don't think Frankie can see who's right behind me.
Yeah, that's what I was just asking her. She can see.
So, well, what about 0? It's actually involved in the first number. What about 0? So you're saying this point's going to be on the line? Is that what you're saying? Something about 0 is involved. It's not that point, though. What are the parts of this equation again? What's the 1/2?
The x.
No, x is the x. What's the 1/2? That's the slope, right? What's the 2?
Y-intercept.
So here's your next definition of the y-intercept. The y, and I might have already said this, the y-intercept number. That is the number where whatever line I draw, wherever this line is going to be, and whatever shape it's going to have, whatever angle, I know it's going to go through the number 2 right here. Because that's literally the definition of y-intercept. It's where my line meets the y-axis. Because remember, the y-axis is the up and down. Get rid of that. The x-axis is the left and right. So the y-intercept tells me where my line hits the y-axis. So I know that has to be a point on my line. Here's the other reason that has to be a point on line. It has to do with what, I think it was you that said it, Aaron. What's my x value at that point there? What would the coordinate be? 0, 2, right? Do you guys see how she got 0, 2?
Yeah.
So which way do I go first when I'm trying to figure out a coordinate point on the graph? Left or right, always, even if I've already got the point and I'm not plotting it. So what is my left and right value? I'm going to go with either. What is my left and right value, so my x value, when I'm at that point? Where would I be on that x-axis? If I'm at this point, where am I at relative to this axis? Am I at the number 1? Am I at the number 2? Am I at the number -5? So what point am I at? What number am I at? 0, right? 0 is in between -1 and 1. So my x value there is 0, and we already know my y value because I'm on the y-axis. All right, I'm not going to go do the next. So that's my coordinate. The coordinate is 0, 2. I'll come back to what I was going to say. Now I just need, and I need 2 points. Can I draw the line right now? Why not? I would love for somebody to tell me where that line goes from there. It is going to go up. But is it going to go up like that? Is it going to go up like that? I don't know yet, right? I only have 1 point. I need another point. I need another point to say, okay, well, now I can connect these two and make the line. So I need to come up with the next point for that. Here's how you do it. And again, no math involved. That's why this stuff is, for some of you, you should do great on this next test. Some of you that aren't maybe as visual might struggle a little bit more, even though you're decent at math. There's not really math involved. This is the pattern to the line, the slope. It tells us where we go to get to that next point. So in order to do that, What's the formula for slope? Does anybody remember that?
Y.
The simple version, not the y2 minus y1 thing, there's a simpler one.
Isn't the y equals m?
That's the formula for the whole equation, because remember, slope is part of that formula, the m. What's the one you heard in 8th grade? Kind of sort of catchy. Something over something.
Rise over run.
Rise over run. So again, write this down. I know that slope, and again, slope is the pattern of the line. It tells me where to go. I know my slope is 1/2, right? Because I picked that out earlier. When you are graphing, this is an easier way to do it than that whole X or y2, y1 thing. We will use that later, but we're not going to use it just yet. My slope is rise over run. So what this tells me is the pattern that I need to follow to get to my next point, and really every other point after that. I'm going to zoom in to make it easier to see what I'm doing. Oh boy, that's going to be super zoom. Super zoom. So from that point right there, and you do not start from here, because we're creating a line from the point we already know is on the line. We're trying to figure out where is the next point from that point. I'll use green for this part. So I know my rise and my run numbers, right? I know that 1/2 is my slope, my rise and my run. So I just need to say, and I always go left to right. Remember, when we're graphing, we always go left to right first, even for this. You may not have done that in 8th grade, but we're going to stay consistent, and we're still going to always do left to right first. You just have to remember, run is left and right. Does anybody run up? You jump up, you rise up. You don't run up. You run left and right. You jump up and down, which would be like your rise and well, it could be a negative or positive rise. We'll get to that. So these numbers can be negative and positive, by the way. So we'll go over that in a minute. For right now, though, they're both positive. So if they're positive numbers, positive run is to the right, because these numbers are getting bigger, right? That's more positive. You're getting more positive. These numbers are getting more positive as you go up. So positive means to the right, or if it's the rise number, it means up. So if I've got a +2, I go over this way, first two spaces. I don't count this as 1, by the way. I go 0, 1, 2, and then my rise number of 1, I go up 1. That's how I do my rise and my run. That's how I get my next point. Now I know where my line goes. Hold on just a second. I'll finish this off, and I want you to try it. Now I have 2 points, and I know exactly where my line goes. My line's going to go through those 2 points and go on forever in both directions. But here's what you can also do. Let's say you don't have a ruler, which sometimes you might not. This pattern continues forever. My run now will still be 2 from this point. So I could go over 2 and then up 1 and put another point. And then I could go over 2 and up 1 and put another point. I could even go backwards. And now I could go over 2 and down 1 just to keep them all in line. Over 2 and down 1. If I'm going left and down, that's a negative and a negative. So -1 over -2 is still equal to a +1/2. So I want 0. I want you to give me the next point in that sequence. Any point, really, that I haven't already done.
On which side?
I just want to see if she can do it since she was on the phone. Can't do it? So this is a really important part of this lesson. So kind of bothers me when I see people, and you were on it for a while, like, wow. Missed probably everything I did for the last 2 or 3 minutes. So I could now connect those points, and again, doing several of them is not a bad idea as opposed to just doing one of them, because it makes your line a heck of a lot straighter when you do finally draw it. So that would be my line that I would create from that pattern, the rise and the run pattern. So look at your, yeah, let me do one more. I'm gonna do one more for you and then you'll start the worksheet. And then you're only gonna do one on the worksheet and then I'll come back and show you something else. All right, so think about, you don't have graph paper, so I'm not gonna make you graph it. Think about, so this is the whole process right here, all in one page. Those of you online, you can take a picture of that. Those of you here, I'll probably print these up or something. You don't have to copy this whole thing down. I'll print it up and give you like little handouts like the step-by-step equation stuff. I'll leave this up on the board in a second though. Or if you want, I'll leave it up and you can take a picture at the end of class. Not right now because I got to leave it. So here's the process. I'm going to go through and I'll do both of these quickly for you. So take any notes that you need. This is mainly because it's recorded, so it'll be recorded for you. So again, first step. I know, zoom in so I can do both of these separately. There. Oops. Already did it. There. All right, so I know my line has got to go through the y-intercept. It's got to hit the y-axis at the y-intercept. So here's step one. I need to find the y-intercept. So I'm going to rewrite this and use addition. So my y-intercept is -3. So the first step, I put a dot on -3. Should have given you graph paper in that packet so you could do this, but just follow along because you're going to do it in a second. Next, now I need to find my second point, and I do that by using my slope. So again, slope. I know it's 3/4, right? Well, that's my rise over run number. So now from this point, I go over, and they're both positive, so that's going to be right and up. If they're both positive, I go right 4, so 1, 2, 3, all the way out to 4. I go up 3. So there's my second point. I just followed the pattern. I went over 4, up 3. There's my second point. Now I just connect them. So that would be somewhere down here. So there's my line. That's the step when you're creating a line. Y-intercept first. Then to figure out your second point, where does my next point go from here? You follow the pattern, which is based on the slope, the rise and the run numbers. And then you just have to remember, positive numbers are right and up, negative numbers are left or down, depending on which, if it's the run or the rise. I'm sorry, yeah, the run or the rise. I'm going to do one more, and then you're going to do the first couple probably on your worksheet, maybe just the first one because I got to show you one more thing. So again, what's my first step? Who have I not called on? So, and I'm not going to probably pronounce it. It's Nai. Anaya. Anaya. All right. I knew it was A-N-Y. I didn't remember. Is there an A? There's an A on the end of it, I'm assuming. Okay. So, what's my first step? Yeah, put a dot on the 2. Simple as that. Just put a dot on the 2. That's why I say you should get a lot of credit on these graphs. It's At the worst case, you put a dot on the 2 and I'll give you some credit. I'll put a dot on the 2. There, you have some points already. You hadn't done anything related to math at all. So now I need to know where's my second point, and my second point is based on the slope. So that's my slope, -3. Don't forget it's a net. What do I know about the slope already? Which means it's going to be sloping down this time from left to right. This is the first one we've done that's been negative. So when I finish drawing it, it better slope down from left to right. So my slope is -3. That's my rise over my run number. What's the problem? Yeah, I don't have two numbers. I don't have a fraction in this one. What do I need to do? Make it a fraction. You make anything a fraction by putting it over a 1. Because any number divided by 1 is just that same number. -3 divided by 1 is just -3. Now I can go ahead and solve it out. So I have a +1. So my run is going to be 1 right. Kind of hard to just do a space of 1, but 1 to the right. Now -3 is going to be down. Because if a positive number was up, then the negative number has to be down. There's my second point. Now again, I just connect them. Using my handy dandy drawing tool, I just connect them. There's my line. All right, so you guys do number 1, not on the first page. Yeah, number 1 on the second page. Just number 1. I mean, I guess you can move on to number 2 if you want. I got to show you one more thing, though, so I'm only going to give you like a minute or 2 to do number 1. You're going to have to do this over the weekend. Oh, yeah, you guys owe me still 3, 4, and 7. Nobody showed me that. So I'm going to be... I'm sorry, you did. You did, yeah. You were absent. So right now, the only one I have is Mariah. And those will eventually be zeros. I gave you a little bit of extra. I just want to see it. So just because I don't collect stuff, you're responsible for showing me stuff if I've already asked for it. I don't keep asking it every single day. Okay, if you remember that one, don't worry.
Where do you put the dot? Where do you put the dot?
I'll have to go back and check it.
Can you go up to the third?
Credit for it.
You
I'm
go
gonna go back and check this. I don't remember this.
down.
All right, so I'll give you another like 30 seconds. All right, hurry.
Right.
I hope you know how to do this.
Right.
No?
Yeah, you're only doing number 1. That's all you're doing. You put a dot on the y-intercept, and then you do the next point based on the slope. Shouldn't take too long. Dot there. What's the slope?
What? 1 over 1.
Well, it's not 1. It's not 0 over 1.
Over 1.
What's the number in front of the x?
Positive. And then up.
No, it wouldn't be there. 0 times x would be 0. There you go. And then you put that over 1.
I didn't really know what we were
Say, oh, I go over 1 and down 1.
Oh, you put the 1 over wrong number. The x is the slope. The number in front of the x is what for number 1? 1. So, and it's not a fraction yet, so how do you make 1 into a fraction? You still put over 1. It doesn't matter what number it is, you still put over 1. So your slope is 1 over 1. Now you should be able to finish it off.
Well, how many do you have to do if you have
That's enough.
So again, you write 1 over 1. So what is your run number?
It's just every square has.
So what's your rise? That's why I say this.
Every square will have that.
Well, you got to start at positive 3.
Never.
So you would start up here and then you would do a shot. And then you're good.
You said just to do 1 and 2.
What's
your y-intercept?
Shoot, I hate these graphs. I needed to give you graph paper for this. Yeah, totally forgot. So you should be drawing in a coordinate plane in the middle like this and putting the numbers on it. Tell you what, Everybody, you don't have to do it right now, but just take one of these and then you don't have to draw that in. You can do 1, 2, 3 on these.
What?
Do you need me to go make copies or something?
No, I've got copies. It's just they don't give them the coordinate plane on these dumb worksheets. They just give them a blank grid.
Well, we're drawing it, they can do it.
Yeah, and that's what I meant to tell them to do, but I hate that they make them do that.
Okay, so rise and rise. Negative side, so what
1
next
over
one's
1.
negative? How's the negative side? Right, over 1, so you write
There
it
you go.
1, so
Well,
from
so
that
you would
side,
actually start up here
over
at 3,
You need
and
one?
then you would go over 1 up. That'd be perfect. All right, so.
No,
You best get it. I mean, I know it's right. I did not.
over 1.
Oh, is this from the other worksheet?
It's, the bottom number is positive, so go over 1, and then down 5.
Right.
And put it up.
But I'm mainly concerned that when you do that, you're gonna. Oh,
Well, let's go down 5 before you do that. That's 1,
And then.
1.
Oh, I'm sorry, I didn't start with that one. Yeah, okay, here you go, that's good. Yeah, that's not, it's not easy, that's.
Okay. Oh, no, that's 4, go 1 more, I'm sorry.
Good. Good, good, good.
Now you can go to, or you could go
So
over
you're
1.
doing these two?
So you have better
So I got
way.
Brian and
Over 1 and
Nicole.
up 5. No.
All right, so I gotta show you one more thing real quick. Remember, this is all recorded, by the way, so.
We'll go off the graph.
So for those problems, again, just come up here, use this graph when you go back and redo it. If you have to watch the video again, you can, but hopefully you remember the steps. Maybe I'll post these steps also somehow in Canvas so you can go and just download the steps, since it's too much to really copy. All right, so the next thing you're gonna have to know how to do is, in addition to creating a line from a graph, you have to know how to create the equation from the line if they already give it to you.
Backwards.
Yeah, this actually is much faster since it's some of the same stuff. We already see the line, right? We got the line. We know one point on that line. Well, I mean, we know a bunch of points on that line, but we know one part of the equation already. So the equation is in this format, y equals mx plus b, right? So here's the process when you're creating the equation from a line they've already given you. Y and x are just variables. They're not going to go away. They're not going to be numbers. They're going to stay variables. So you literally just do this as step 1. Write that in. None of that will change. Always be the same every time. Now, you might put numbers in there later that replace them, but you can always start out with that. Won't ever hurt you.
That's your skeleton.
So this will be how you do 4, 5, and 6. Yeah, it's your skeleton template. Skeleton better for them. Now I just have to fill in 2 numbers. I just need to know, well, what is my slope? And what do I know about the slope of this one already? What did I say? The first thing you should think about slope. What do I know about the slope of this blue line? So it's going up, so it's what? Positive. So I know this is going to be a positive number. If I don't get a positive number after I do the math, I did something wrong. So what do I also know about that last part? What is that last part? What do we call it? What do we call this? That's the y-intercept. What did I say the y-intercept is visually? Actually, sort of what one of the definitions of intercept means. How did we draw the line when we were given that number? What did we do? What was the first step we did? Like the very first step you did when you just drew that line. What did you do? Mm-hmm. Put a dot where? So if I had this equation, the first thing we did is we put a dot on the 3, right? Because that's the y-intercept. That's where my line is going to hit the y-intercept. I know that. That's by definition. That's where the line's going to hit. So that means I can put a dot there. Well, we're just going backwards now. We see where the line is hitting. That's my y-intercept right there. So if that's where my line is hitting, that's the last part of my equation. That's where my line is hitting the y-intercept. So I just write in -4. Now I need to figure out the slope, which is, again, the same process, only this time I'm doing it backwards. I don't know the numbers, but I know the slope is rise over run. So I need to figure out, well, what is my run number and what is my rise number if I want to go from this point to any other point on that line. Doesn't matter which point I choose. It'll always work out the same. Might be different numbers, but eventually when you reduce that fraction, it'll be the same number. Here's a key you need to write down in your notes. And it's actually in the other, maybe you don't need to write it down. I need to pick a point on this line that is on the corner of squares. So here's a corner, here's a corner, here's a corner, here's a corner. The reason why it has to be a corner is if I pick this number right here, or that point, I don't know what number that is. That might be 1.2, it might be 1.3, like I can't tell what number that is. So I don't really want to pick that number. It'd be a lot easier to pick a number. Oh, that's not part of this equation. It'd be a lot easier to pick a number that was, say, right here. Because I know what that is, for the most part. What coordinate is that? It's 2, 0, right? I see that it's going right through the 2 and right through the 0 for the y. Now I can count and come out with nice round integers that I can use to do my slope. So again, which way do we go first? Left and right. Always left and right first. Whether we're graphing, whether we're doing slope, doesn't matter. So I said earlier that the slope is actually the vertical distance divided by the horizontal distance. So how far over am I going if I'm going to go left and right and then up and down to get to that point? How far over am I going? 2, right? I'm going from here to there. So then how far up am I going? 4. So my vertical or my horizontal run is 2. My vertical is 4. So like I said, the fancy definition was it's the vertical distance, which is just 4. That's my up and down distance, divided by the left and right distance, which is the distance between the x's. So you really could just subtract. So I'm at so this point right here is 2, 0, and this point down here is 0, -4. I really could just subtract the difference or the distance between my y values and get my rise, and I could subtract the distance between my x values and get 2. And we're going to do that later. I don't want you to worry too much about that now, but I want you to understand the slope is just the vertical distance divided by the horizontal distance. So now I have my slope. What is 4 divided by 2? It's just 2, right? So I can go ahead and convert that into 2, and that's your equation. That's how you do the equation when they give you the line. So you should have all grabbed this so that you can use these, and you don't have to draw out on those little tiny graphs. You don't have to draw out an x and a y. If you didn't grab one of them, come grab one. So make sure you attach that to that whole packet when you do it, or just make sure you bring it in and I can attach it. But either way, make sure you have that page, unless you draw your own x and y in, which I'm fine with that if you want to do it, but it's not as easy. So this is due to me. Bring it for sure next Monday, because we'll probably work on it. I probably won't grade it till Wednesday, though.
Monday.
Tuesday. So Tuesday and Thursday probably for you guys. But if you don't do it on your own, we're not going to do it in class. So you're still going to have to do it on your own at some point. But at least if you try to work on it over the weekend, you can come to me and say, hey, I didn't know how to do this. And I can help you a little bit in class so that you kind of have it done without having to do it on your own. You should still be really working. All right, so if you're packing up, stay in your seat. Or a seat. You can move around, but be in a seat. I don't want people standing up around my class, is basically what I'm saying.
My daughter's coming to visit, so I get to spend time with all three of my daughters and my grandson.
For Halloween?
For all,
Going
the whole
trick-or-treating?
weekend. No, it's my birthday. We're going to honeymoon island.
Oh, you have a Halloween birthday.
It's the 3rd, so we're,
Oh.
but we're doing it on the weekend.
All
I've never been to honeymoon island.
right, so you guys online, you can, okay, see ya. You can upload this either, there's an assignment in Canvas. Oh wait, I'm sorry, no there's not. So you have to upload it in Focus for you guys online. There's an assignment in Focus. It's just called Linear Equations, I think 2-1, and it's got both worksheets in it. So have this to me. The deadline is really Wednesday, kind of like I'm doing with these guys. I guess Thursday for you too, but you guys can do it anytime because you can just upload it in a day when I don't see you. But the earlier you upload it, the better, because sometimes I'll give an extra point or two when you guys get it in on time, which is really should be Tuesday.